Welcome back again, class. Thank you for joining me for Chapter 8. Today we're going to continue discussing inverse variation, but we are going to learn how to construct formulas using it and formulas that use more than one relationship. If you involve multiple variables, you can have things that have an inverse piece and a direct piece, and we're going to cover those combined variations today as well. So when we're constructing formulas, remember the two basics. When they vary directly, x goes with the k. They multiply each other like this. So again, think linear when you're talking about direct variation. When varying inversely, x goes on the bottom, all right, like this. Again, thinking proportionately, thinking ratio. So that's one of the big ideas here. Direct, x goes on top with the x. Inverse, x goes on the bottom, away from the constant. So let's take a look at our first example. The perimeter P of a square varies directly with its side length. When side length is 5, the perimeter is 20. Find an equation that relates these variables. All right, so the perimeter P varies directly with its side length. So varying directly, oops, I'm sorry, that shouldn't be x. Varying directly means it goes with the constant of variation. Okay? Again, so direct means it goes on top. It stays with that constant of variation. When the side length is 5 centimeters, the perimeter is 20. All right, so I'm going to plug that in. So the perimeter is 20, and the side length is 5. Find an equation that relates the two variables. All right, well, I can use this to find the constant of variation. Because to find the constant of variation, don't I just have to divide by 5? So I can get that the constant of variation is 4. All right? So now that I have that, remember that's not my equation. I found the constant of variation. The equation is when I go and I plug it back in. So my equation is P equals 4S. Which shouldn't surprise you. Isn't that kind of a geometric rule that you learned? The perimeter of a square is 4 times any side length because all the side lengths are the same. All right. Let's move on to our next one. So according to Boyle's law, the pressure P exerted by a gas varies inversely to its volume V. So first I'm going to get that set up. All right. So the pressure exerted varies inversely. So this time the volume is going to go on the bottom. Inversely means that variable goes on the bottom. The constant variation always on top. Inverse is telling me the variable goes on the bottom. When neon has a pressure of 4 pascals, it has a volume of 12 cubic meters. Find an equation that relates these variables. All right, so I'm being told neon will have a pressure of 4 and a volume of 12. So I plug that in. So I have 4 equals K over 12. So if I want that constant of variation, all I have to do, multiply that 12 over. So I'm getting a constant of variation of 48. All right. Now, again, that is not the equation. The equation is when I take that and I plug that back in. So for this particular gas, for neon, I'm getting P equals 48 divided by its volume. And there you have it. All right. Let's keep moving through our examples. So, the number of bags of grass seed N needed to reseed a yard varies directly with the area needed to be seeded and inversely with the weight of a bag of seed. Find an equation that relates the variable if it takes two 3-pound bags to seed an area of 3,600 square feet and use it to determine how many bags will be needed to seed 9,000 square feet. All right, so the first thing we have to do is figure out the structure of the equation. So the number of bags, so N. This says it varies directly with the area. So that means when I'm setting this up, the area goes on top. Direct means it goes on top with a constant variation. And inversely with the weight of the bags. All right, so there's my basic setup, okay? So again, the direct piece goes on top with the constant variation. Any inverse piece will go on the bottom. Now I'm going to focus on this piece, okay? Because it tells me that it takes two 3-pound bags. So two 3-pound bags, so that's giving me two pieces of information. It's telling me the number of bags and that the bags are 3 pounds. And I'm getting an area of 3,600. All right, so I plug all of that in, okay? Now, I need to get that K value. So to find that K value, the first thing I'm going to do is I'm going to multiply that 3 over. So 6 equals 3,600 K. I divide by 3,600, so I'm getting K is 1 over 600, because 6 divided by 3,600 is 0.0016, and then that 6 repeating. I got my calculator to turn it into a fraction for me, and that's what I get. So, again, I'm going to put that in for my actual equation. So K is 1 over 600 A over W. So there's my equation. And now I want to know how many bags will it take to seed 9,000 square feet. All right, so 9,000 square feet. That's giving me my area. And if they're referencing the same bags as before, the weight of the bags was 3. All right, so we need to determine how many bags we need. So we take 1 over 600 times 9,000, divide that by 3. So I'm going to end up needing 5 bags in order to do that job of 9,000 square feet. All right, let's keep moving. So if x varies jointly with y and z, it means that it varies directly with both. It can be written as y equals kyz. So if you see that they vary jointly, all that means is that it varies directly with both things. So let's take a look at our next example. The number of bags of mulch you need to cover a planting area varies jointly with the area to be mulched and the square feet, or in square feet, and the depth of the mulch, d, in feet. Find an equation that relates the variables. If you need 10 bags of mulch, or 10 bags to mulch 120 square feet to a depth of 3 inches. Use the equation to determine how many bags you need to mulch 200 square feet to a depth of 4 inches. All right, so the first thing is it says that they vary jointly. So that means if N varies jointly with both the area and the depth, jointly means both go on top. Okay, joint means direct. Now, one thing to watch out for, okay? So notice in square feet, in square feet. But then notice those couple of values given. So we're supposed to be talking about things in terms of feet. However, notice we're given some units in inches. So we do have to make sure that we convert those. So 3 inches, 3 divided by 12, so that is going to be 0.25 feet. 4 inches, that is going to be 1/3 of a foot. 4 divided by 12. So do make sure you're working with the proper units. Okay, that's one little trick to this one, is you have to make that conversion to feet. But now let's plug in what we know. So I'm going to use all the information from here to here. Find an equation that relates to variables. If you need 10 bags, so that's going to be N, 10 bags to mulch 120 square feet to a depth of 3 inches, but again, we already converted that to 0.25 feet. So I'm going to take that and 120 times 0.25. So right now my equation is K equals, or 10 equals K times 30. I'm going to divide 30 from both sides. So my K actually ends up being 1/3. All right. Now, again, that is not my equation. That is my K. I have to take that and plug it back up there. So N equals 1/3 AD. That is my actual equation for this instance. Now the second piece, it wants me to use that equation to determine how many bags you need to mulch 200 square feet to a depth of 1/3 foot. So let's plug that in. 200, then 1/3 foot. I type all that into my calculator. So 1/3 times 200 times 1/3. That's going to be about 22.2 bags. Well, 22.2 repeating bags to be precise. But again, we're probably going to want an exact number of bags. So really, that would be about 20 bags to do that job. All right. Gravitational potential energy is a measure of energy. Potential energy varies directly, jointly, with the object's mass and height in meters above the ground. Physicists use G to represent the constant of variation, which is gravity in this case. The skateboard in the photo has a mass of 58 kilograms and a potential energy of 2,273.3 joules. Use this to find an equation relating the variables. What is the gravitational potential energy of a 65 kilogram skateboarder on the half pipe shown? All right, so first let's get this set up, shall we? So it says my potential energy varies jointly, which it even clarifies directly, with his mass and his height, and his height above the ground. So, so again, that's what jointly means. It means they have to relate both directly. All right, now I'm going to use the information in the rest of it. So the information from there that's given to determine what that K is. And in this case, I apologize. They were actually using G. They said to use G instead of K. So the skateboarder in the photo has a mass of 58 kilograms. So I'm going to put that right there. Has a potential energy of 2,273.6 joules. And something, I know it might be hard for you to see in yours, but in the photo, it gives a height, okay? It says his height is 4 meters. And we're going to use that to determine that constant of variation, which in this case, they're actually letting G represent our constant of variation. All right, so first, 58 times 4, that gives us 232. So if I want G, now I have to take that 2,273.6 and divide it by the 232. And you actually get that G is 9.8. Now, for those of you that have had any physics, okay, you will learn that that is actually a constant. That is the constant acceleration due to gravity. And again, if you haven't had it yet, you'll get there. Now, remember, the equation comes from plugging that in. So my potential energy is 9.8 m times h. So I have my equation now. So now I can finish this up. So they're asking for the potential energy of a skateboarder who is 65 kilograms and on that same half pipe shown. So the height is going to be that same 4 as shown below. So I take that 9.8 times 65 times 4. I'm going to get their potential energy is 2,548 joules. That is their potential energy. All right, now, for those of you that like to have structures, there's a little summary below. Now, keep in mind those are just samples, okay? If you can do what I did throughout this lesson and just piece it together, direct meaning on top, joint meaning on top, or inverse meaning the bottom, if you can do that, I think that's more useful than trying to memorize that table. However, I did give it to you just as a reference point if you wanted to be checking things out. So that is all of our notes for today. Thank you so much for joining me. And make sure you have all this written down and so you can come back ready to do your practice work.